Hi there, this is Rick Powers from Western Technical College. I'm going to do a quick explanation of something called Newton's method. What's Newton's method? Well, the idea behind Newton's method is that we're going to use the derivative to help approximate a root. So what I want to do is I want to figure out if I have a function like this. I want to figure out where it actually crosses the x-axis here. And if you think about this situation, if we knew that we had a straight line, well, it'd be very easy to find that number. But if this is a curved line, we don't necessarily know where that is. So what we're going to do is we're going to approximate by using the derivative here to find a place where we can actually make that happen. We want to find out where we could approximate that thing as a line. And so then that'll give us a guess. Instead of going from here to a curve, we say, well, what if this were straight right here? Well, if this is straight, if we use the derivative, then it's going to be a little bit off. And then we say, okay, well, it was a little bit off. But then the trick here is that we're going to use this and we're going to say, all right, well, I was a little bit off. Let's use this as an approximation. Then that'll make another straight line here, which will again make this a little bit off. So it's a little bit off all the time, but if we keep going, we're hoping that it'll actually end up to be on that point. Now, your textbook goes through and explains how this works, but the basic idea is something called iteration, where we have something where we start with an initial number, x sub n, and then we generate another one, x sub n plus 1. And the way that we do this is we take the function divided by the derivative, evaluate it at that point. Now, even though this is true and it works, sometimes it doesn't work all the time, because this was assuming that we had something that was relatively decent in terms of its behavior. If this thing bounces around at all or has like maxima or minima in here, this is just not going to work. And so even though it's a useful idea, I'm going to rewrite this here a little better. Even though this is a useful idea, it doesn't always work. And in addition to that, in order for this to happen, we have to know the derivative at a particular point. I need to know the derivative here in order to know what this tangent line is. Well, if this is really fairly complicated, then I'm not just going to be able to figure that out. It's going to take some complicated math for me to know what this number is for the derivative. And then once you get to that point, it's like, well, I'm using my computer to do all this, right? Or I'm using my calculator to make all this happen. Why don't I just graph this and find out where that is? And so that's normally what we would do. I mean, what a normal person would do, right, is that if you say, I want to know where that number is, well, let's just graph it and then just zoom in as much as we want to and find out what that is. Now, the truth, though, is that when you talk about how do mathematical people find roots of things, how can you get this number and use a computer to find it quickly instead of using just the zoom in process? Well, this would be a way for that to happen. So it's in the textbook, it is used, and it is positive in the sense of it's a good thing to know. but it's not something that it's um, that useful for us in terms of understanding the application of calculus, just because it it goes through a process that we could just as easily do if we had a graph. Just find this place. And certainly with Wolfram Alpha, we just type it in and say, what's the root? And it can tell us. However, again, to be able to use this in order to make this um, a way to find values of a function is pretty common. And it's something where you get into the idea of what's called numerical analysis. Numerical analysis is the process by which people use computers generally to figure out stuff that algebra can't find. And there are no other real methods to find an answer. And so you have to use numerical analysis. You have to use approximations, and then you have to be able to control them. You have to be able to understand them. Why is this getting close to the true value? Is this actually the true value? Or is it going to give me a mistaken answer or something like that? So numerical analysis is a very important part of mathematics, but it's just not that useful for us. So even though it's a good idea to know how to do this, it's not something that I think we need to work on that much. So I wanted to show you how it works on the video, but I'm not going to put it on an assignment, and it's certainly not something that I would put on the test. So that's my understanding of Newton's method.